In the grand theater of the cosmos, Earth has long been the only known stage for life. But now, a new discovery could rewrite that narrative. Imagine looking up at the night sky and realizing that somewhere out there, another civilization might be doing the same, only instead of starlight, their nights are illuminated by artificial city lights. This seemingly fantastical concept has taken a step closer to reality, as recent astronomical studies point to something remarkable: the potential detection of artificial illumination on a planet beyond our solar system, Proxima b. Located just over 4.2 light-years away, Proxima Centauri is the closest known star to our solar system. Orbiting this red dwarf star is Proxima b, a rocky exoplanet residing within the star's habitable zone. This planet has been a source of fascination for scientists since its discovery in 2016. But now, it's capturing the imagination of the entire world for a very different reason. One that could redefine our understanding of life, civilization, and our place in the cosmos. The search for life beyond Earth. For decades, the scientific community has been engaged in the search for life beyond our planet. We've sent spacecraft to distant moons, pointed powerful telescopes toward faraway stars, and listened for radio signals that might hint at intelligent life. Despite these efforts, Earth remains the only confirmed cradle of biology. However, that might be changing. The discovery of unusual patterns of light coming from Proxima b has raised serious questions. Could these lights be artificial? Are we witnessing the glow of alien cities? Or is this merely a misinterpretation of natural phenomena? To understand the significance of this claim, we first need to understand the methods used to detect such distant signals, and why Proxima b has become one of the most watched planets in our galactic neighborhood. Why Proxima b matters. Proxima b orbits within the Goldilocks zone of its parent star, Proxima Centauri. This means it's at just the right distance where temperatures could allow for liquid water to exist on the surface, a key ingredient for life as we know it. With a mass about 1.2 times that of Earth, and likely a rocky composition, Proxima b is one of the most Earth-like planets discovered to date. It also has one major advantage: its proximity. At just over 4 light-years away, it's practically next door in cosmic terms. That makes it an ideal candidate for detailed observation and analysis. If intelligent life exists anywhere beyond our solar system, Proxima b might be the first place we find it. Unusual light curves. Clues from the darkness. The recent excitement surrounding Proxima b stems from the detection of irregular light patterns, specifically, fluctuations in the planet's brightness that do not align with known natural causes. Astronomers have been using photometric analysis to monitor how light from Proxima Centauri dims as Proxima b passes in front of it. This method, called the transit method, allows researchers to study the planet's size, orbit, and atmosphere. But now, researchers have begun noticing something even more curious. As the planet rotates, the dark side, facing away from its star, shows brief and subtle increases in brightness. These increases are not consistent with reflected sunlight, auroras, or volcanic activity. Instead, they resemble a structured, rhythmic glow, one that could potentially be artificial in origin. The case for artificial illumination. Artificial light differs from natural light in several key ways. For one, it tends to emit in very specific wavelengths, such as those produced by LEDs, halogen lamps, or sodium vapor lights. When researchers compared the light curves of Proxima b with expected natural light reflection models, the differences were clear. The fluctuations weren't random. They appeared to follow a repeating cycle, one that suggested intentionality. And that's where the speculation began. Could it be that Proxima b is home to a civilization that, like us, lights up its cities at night? Could the glow we're seeing be the alien equivalent of our street lamps, stadiums, and skyscrapers? While the idea is thrilling, the scientific community has approached it cautiously. Extraordinary claims require extraordinary evidence, and scientists are careful not to jump to conclusions. Nonetheless, the data is intriguing enough to warrant further investigation. If the lights on Proxima b are artificial, what might that imply about the civilization behind them? First, it would suggest technological advancement, perhaps equivalent to or even beyond our own. Constructing and maintaining city-wide lighting requires significant energy infrastructure, urban planning, and societal organization. It implies the existence of power grids, manufacturing, and likely some form of governance. Second, it would suggest that this civilization exists on the dark side of Proxima b. Many astronomers believe the planet is tidally locked, meaning the same side always faces the star, while the other side remains in perpetual night. If life developed on this planet, it might have evolved in the temperate zone between the scorched day side and the frozen night side, or even exclusively on the dark side, where artificial lighting would be a necessity. Third, it opens up questions about communication. If such a civilization exists, is it trying to contact others? Are these lights a form of signal? Could they be sending out directed beams or modulated pulses designed to catch our attention? These are the questions now being considered by astrophysicists and SETI researchers alike. The role of future telescopes right now, the data is tantalizing, but far from definitive. However, upcoming technologies may change that. The James Webb Space Telescope, JWST, launched in 2021, is designed to study the atmospheres of exoplanets in incredible detail. By analyzing the way starlight passes through a planet's atmosphere, JWST can detect the presence of gases like oxygen, methane, carbon dioxide, and even industrial pollutants, chemicals that don't exist in large quantities naturally, but are byproducts of technology. If JWST or future telescopes like the Extremely Large Telescope, ELT, or LUVOIR detect such compounds on Proxima b, it would be another major piece of evidence pointing to intelligent life. Another strategy involves studying the polarization of light. Artificial lighting tends to be highly polarized, meaning the light waves are aligned in a particular direction. Natural light, in contrast, is typically unpolarized. Instruments capable of detecting polarized light from exoplanets are now in development and could provide another method of distinguishing artificial sources. Other possible explanations, of course, not everyone is convinced. There are many alternative explanations for the light anomalies. One possibility is auroras, natural light displays caused by charged particles interacting with a planet's magnetic field. However, auroras usually emit in specific colors and intensities, which don't match the Proxima b observations. Another possibility is star spots or flares from Proxima Centauri itself. Red dwarfs are known for their erratic behavior and frequent solar flares, which can affect nearby planets. However, the light patterns observed on Proxima b seem localized and consistent, making this less likely. Finally, instrumental error can never be ruled out. Sensitive telescopes picking up faint light over astronomical distances are always at risk of misinterpreting data due to calibration issues, background noise, or data processing flaws. That's why repeated observations, using multiple instruments, and peer-reviewed verification are essential before making any bold declarations. Philosophical and cultural implications. Even without confirmation, the possibility of artificial lights on Proxima b has sparked widespread curiosity. For centuries, humanity has wondered if we're alone. Every religion, philosophy, and scientific field has addressed this question in some form. Finding intelligent life elsewhere would challenge deeply held beliefs and redefine our understanding of biology, technology, and our role in the universe. It would raise ethical questions too. How do we approach a civilization more or less advanced than ourselves? Do we attempt to make contact? Do we observe quietly? Or do we leave them alone entirely? It also brings practical considerations. If intelligent life is this close, just 4.2 light-years away, it means the galaxy might be teeming with civilizations. And if they're using artificial lights, who's to say they aren't observing us too? The long road ahead. As with all major scientific discoveries, progress takes time. More data is needed. More tools are being developed. The science is advancing steadily. Astronomers continue to monitor Proxima b with excitement and caution. New instruments are being brought online. International collaborations between observatories are forming. And theoretical models of artificial illumination are being refined to match the specific characteristics seen in the data. But one thing is certain. We are closer than ever before to answering one of the oldest questions known to humanity. Are we alone? The glow on Proxima b could be a natural wonder. Or it could be the beacon of a distant civilization, shining out across the darkness of space, as if to say, we are here too. This is Space Loop, where science meets wonder. Stay with us as we uncover the mysteries of the universe, one discovery at a time.